It's finished. Hey there fellow geeks, nerds and makers, Mark here, and I've just finished off this almost 2-month-long build of a Revell 1:2700 scale Imperial Star Destroyer. Want to see how I did the build? Keep watching. I don't think it's much of a secret how big of a Star Wars fan I am. When I was a kid, I grew up on Star Wars, and there were two ships in particular that always caught my attention: the Millennium Falcon and the Imperial Star Destroyer. Given the chance, I had to build one. And one day, while surfing around eBay, I found a Revell 1:2700 scale Imperial Star Destroyer. Of course, it was on the other side of the planet, but I wasn't going to let a little thing like that stop me. The Revell Star Destroyer is a rebadged version of the Zvesda Star Destroyer, a Russian-created model. Now, the interesting thing, though, is even though I've bought the English version of the model, the kit I bought still shipped from Russia. Once I got my kit, I sat on it for a couple of months thinking about exactly what I wanted to do to it. Did I want to make it pristine and light up? Did I want to paint it crimson? Did I want to crash it into the sands of Jakku? I decided to go old school, as you can tell, and make it pristine and light up. So I jumped online once again, and this time I bought a reel of 350 meters of 0.5mm optic fiber cable and 2 different packs of 0.5mm drill bits. And when they arrived, I started the build. Why don't we just go check out part 1 of the build? So in that build video, I built the model kit, I drilled a ridiculous amount of holes, I threaded lengths of optic fiber through the holes, figured out the best way to adhere the optic fibers to the model, and then made the cables fairly neat, attached LEDs, blacked out the interior, and it took way longer for all of that than the few minutes you just saw in the clip. In fact, let's talk about some of the statistics that went into me making this. It took me a couple of months, and during that time, just drilling the holes, feeding optic fiber through, took 3 whole days whilst I was on holiday. If that seems like a long time, you're completely right. I worked my way through several different channels on YouTube, I listened to my entire backlog of podcasts, and I was questioning my decision and my sanity by the start of day 2. Fortunately, it all kind of worked out on day 3, and I was able to see the lights in the end of the tunnel, forgive the pun. I could fire up my LEDs and see them illuminated on the Star Destroyer, and as you can see, it's totally worth it. At this point, I would like to share a few lessons learned with all of you. Number 1, working with a 0.5 millimeter drill bit is a nightmare. I went through more than 20 drill bits on this project. And the funny thing is, drill speed really matters. If your drill is too slow, you're more than likely to break it due to pressure and torque on the bit. If it's too high, you melt the plastic, which makes it difficult to use, it makes a non-uniform hole, and it makes it impossible to feed the fiber optics into, but visually you can't tell the difference. Eventually, I was able to dial my rotary tool in until I could get pressure on the drill bit and it would remove material without melting it. I also found that feeding a 0.5 mil optic fiber into a 0.5 mil hole, while it might sound like the logical choice, is actually quite hard to do. And all it takes is a slight kink in the end of the optic fiber where you've cut it off and it will not feed into the hole and it will bind on the edges. The solution to this was only found after I went through all 20 of my 0.5 mil drill bits. I bought a PCB drilling kit of hardened steel from my local electronics store, and that had a variety of drill bits. The 0.56 and 6.2 millimeter drill bits were much better, and I found that I was moving material a lot better and able to feed the optic fibers in a lot faster. Any larger than this though had problems though, as the fibers would fall out of the holes easily. That little tiny bit of friction is vital to holding them in place. Another challenge I came across was adhering the fiber optic cables into the chassis itself. I needed to glue these in so they would stay in place and not fall out, but also to add some structural strength into the cables as I was manipulating a lot, and I figured they might be likely to bend at the natural kink points of where they're entering the fiber on the model. This is my first ever time working with optic fiber cables, and I picked up 350 meters of it from an online retailer. I did find out that different glues interact very differently with different cables. The first glue I tried was cyanoacrylic glue, or your regular super glue. At first glance, this seemed to work really well as it didn't impede the ability of a cable to transmit light. However, it did make them very friable, very brittle, and meaning they could no longer withstand any manipulation as they would just break off wherever I glued them. This was definitely not an option, as even simple manipulation led to a lot of my fibers breaking off. After I tried CA glue, I switched to trying a hot glue gun. Love using hot glue, and it seemed pretty successful at first, but unfortunately 0.5 mil fiber strands are so thin that the hot glue gun would melt them upon application, resulting in the strands of fiber being adhered but no longer actually transmitting light clearly. So hot glue and super glue were not options for me to use. Out of desperation, I decided to give PVA glue, just ordinary wood glue, a try. I painted on a large blob at the base of each fiber, and this worked perfectly. No breaking, no melting, no shattering, and better yet, the large blobs I was putting on worked to adhere and add rigidity and strength to the base of the strand where I thought it would be most likely to break off. Wood glue is also fairly flexible after drying, which means I could manipulate the fibers with no problem at all. Light leaking was a little bit of a problem, and by this stage I've got up to 30 LEDs inside this shell, with more to come. So I decided I needed to deal with this. Fortunately, I hadn't closed the chassis, so I could deal with it 2 different ways. The first of which was I sprayed the entire interior with a very thick coat of black paint, which stopped the majority of the light leaks straight away. I also wrapped up the outside of my LEDs in heat shrink tape, and then I surrounded that with aluminium tape. The aluminium completely blocks light, which means almost all of the light sources inside of the hull were eliminated. And the black stopped any tiny bits of residual light from bouncing around inside the hull and coming out any gaps or holes. The only other thing I will mention here that I would not do again was assemble the bridge of the Star Destroyer the way that I did in the video. I drilled all the holes, pulled the fiber optic cables in, and then attached the LEDs inside of here and sealed it all up, leaving the electrical wires from the LEDs down a hole at the back of this structure and into the main body. This method had a couple of problems. One, there was very limited room inside of this bridge, which means I had to jam everything in, and when I was doing the glue up, it resulted in a less than perfect seal. Not a big deal, but I had to fix it up. And two, I couldn't get back in there to fix any issues or change any of the LEDs. Fortunately, there weren't many problems, so it was pretty easy to deal with. And while none of these were deal breakers, it would have been far more efficient to simply use much longer individual strands of optic fiber, which led down into the main cavity of the hull. So, that's this video wrap. Thank you for watching part 1 of this build. Part 2 is just around the corner, and in that video I'm going to show you how I took it from an illuminated model to a fully painted model with this lovely base and weathering on the Star Destroyer. Now, a friend of mine by the name of Rob Pauser has been working on his own Star Destroyer, and his has a bit of a twist though. Instead of this massive 2-foot long monstrosity, this is palm size, and it looks equally amazing. That's it for this video. If you have any suggestions on any other techniques that might have been more effective, or if you have a suggestion on what I should be building next, drop me a comment down below, as I would love to hear from you. If you've liked the build and want to see part 2 of this build, make sure you hit the like and subscribe buttons for the next chapter, which will be out in about a fortnight. Thank you for watching, and before you go, I'm going to share a preview of my friend Rob's Micro Star Destroyer build. The link to his channel is in the description. See you in part 2.